at that point in the year when we're going to practice non-sterile compounding utilizing USP 795 standards. So this is the paint lab. This is when we practice measuring and mixing. So today we are going to pretend to compound a medication while making paint. The steps we're using can easily be related to non-sterile compounding. We will practice the following skills: locating information on a stock container, gathering information for a compounding record, measuring liquids and solids, overall safety, calculating percent error, determining beyond use dates, translating SIG codes, filtration, spatulation, and cleaning. So first off with our lab, what we want to do is just make sure that we're ready to begin work. So the first step in any kind of compounding procedure is to make sure your hands are clean. So now you would sit there and wash your hands. So this is my pretend sink. After that, you want to get a pair of gloves. Usually you'll use nitrile just because there's a good amount of people that have latex allergies. And since this is non-sterile compounding, we don't have to use sterile gloves. Next, you want to make sure your work surface is always clean. So we can do that with 70% isopropyl alcohol, which is what you always use to clean pretty much anything in any kind of pharmacy environment. If you're doing sterile compounding, you'd use sterile isopropyl alcohol, but here you would just use regular isopropyl alcohol. So you just want to make sure your work surface is clean. Any kind of devices or ointment slabs or whatsoever that you're using is clean prior to working. So the first step in this lab is to just verify information before you start compounding, verifying information of your the ingredients that you're going to use to compound. So here, our first ingredients that we're going to need to mix up in our paint lab would be flour and salt. So for the flour and salt, I put little labels on here. You just have to verify information. And this is really important to do when you're actually compounding medications, because one of the things you need to verify is an expiration date, and if you're making a compounding product, you always want to make sure that the patient is aware of when ingredients that you're using expires. Normally, though, whatever you're compounding will expire before the expiration date on the products that you're using. Another reason why it's really important to verify this information is it helps just kind of double check yourself that you chose the right product to then mix up to compound. In pharmacy, we always measure solids using a form of grams. We don't measure using liquid units like a lot of times you do if you're baking. So here, just to make it easier for you guys to scoop, I told you guys that it would be about 5 milliliters or 1 teaspoon. But we're going to weigh it out just to make sure everything is accurate. So here are our scales. And here are our weigh boats. Weigh boats are usually used to measure powders. Turn on my scale, have it set to 0. I'm going to put the weigh boat on it. Right now it says 2.37 grams. I'm going to tare that to make it say 0. Now I can take my weigh boat off and add. First I'm going to do the salt. You can do either one first. And I'm going to try to get it to the amount of salt that we want with a 5% of error. Okay, that's really close, so that's within the 5% error range. And I'll show you guys right now how to tell if it's within that 5% error range. So when compounding in pharmacy, you always want to make sure that your products are within a 5% error range. It could be less than that depending on what the pharmacist wants, but a general rule of thumb is that you should be within 5% error. You can make sure that you're within 5% error two different ways. So the first way is to find the exact percent of error after you measure something. So this would be every time you're measuring something, you would have to go back and do a calculation. Or you could just calculate your range that you need to be within, which is my preferred method. So first, let's look at calculating the exact percent of error. So I gave you guys the little equation here that I would use for that. So you take your measured amount, so whatever you actually measured when trying to get the expected amount, you subtract it by your expected amount or the amount you're trying to find. You divide that over your expected amount and you multiply that by 100. And this will give you your exact percent of error. And then you can see if that is within that 5% range. If it is, it's good. If it's higher than 5%, then you would need to remeasure. The second way, as I said, my preferred way is to calculate your range expected from your 5%. And to do this, you would find what 5% of that amount is, whatever your expected amount is, and you would then make your range by adding that 5% to your expected amount and subtracting it from your expected amount. You take those two numbers together and that's your range. So let's look at a couple examples. Okay, so our example is we are trying to find 5 grams within that 5% error. So let's just say we weighed out some powder and we found 4.9 grams. And we want to know if that's within 5% error. And let's just say we want to first do the method of finding the exact amount of error here. So we would take our 4.9 grams, subtract that from our 5 grams, divide that from our 5 grams, and then multiply that by 100. And I'm doing this just by plugging our amounts into our given formula. Measured minus expected, divide by expected, times 100. So here we have measured minus expected, divided by expected, times 100. So if we actually do the math here, we get negative 0.1 divided by 5, which would equal negative 0.02, times that by 100, and we get negative 2%. When we say 5% error, we mean plus or negative 5% error technically. So because we're not 5 units off, this would actually work. This would check out. Okay, so next we're going to use the same example of the 4.9 grams, but we are going to use this formula. Expected times 0.05 equals 5% of that amount. And then we're going to write our range down and make sure that whatever we're measuring falls within our range. So that way you don't have to keep doing math equations. You can just do this once. And if you keep having to go back to remeasure things, you're good. Okay, so here our expected amount was 5 grams times 5%, 0.05. And if we do that, we get 0.25. So remember, then we're going to have to plus and minus 0.25 from our original 5 grams. If we do that, we end up with a range of 4.75 to 5.25 grams. So anything within this range would check out. And remember, we measured 4.9 grams. That was our original measurement. We were trying to figure out if that would check out. So as you can see, 4.9 grams would fit in this range, so it checks out. All right, so salt is done. Let's do flour now. That's a little too much, so I'm going to put a little bit back. Still a little too much. Just a little bit more, but we're very close. Okay, we're good. So now that I have both of my powders measured out within our 5% error range, now we want to triturate, which is when we're going to reduce our particle size of our powders, mix them up using a pestle and mortar. So put that in there, put that in there. And these are about equal amounts, so we don't have to use geometric dilution, which is what you would use if one of these powders was much smaller in amount than the other. And that's when you would try to keep adding them in at a 1-to-1 ratio. Just make sure everything is well incorporated. So right now, as you can see, I'm really trying to grind at the sides. I'm not just like kind of mixing around like this. I'm really trying to reduce that particle size. The powder is a little thicker, so if you don't really triturate well, then you're going to have a thicker paint. Okay. So now we're going to take our mixture and we're going to move to the other table. So now we have our mixture. We're going to put it in the center of this artist palette, which is going to resemble our ointment slab. And then we're going to put our mortar back. Now, just because it's going to be difficult to pour this into a graduated cylinder, just like that, and because we can practice our pipetting skills, we're going to take a pipette and we're going to fill it up. Each of these pipettes are 3 milliliters, and we want to get 6 milliliters in the graduated cylinder, so we're going to go about 2 times in order to have enough. So you use the pipette by squeezing the top, it draws the liquid in, and you can see here that the top of the pipette has a line. So these pipettes go up to 3 milliliters. For this, you always want to measure at the bottom of the meniscus, which is the curve of the water. So looking at this, I can see right now that I have a little bit more than I need. So I'm just going to put it just a tad back. I think that was a little bit much, yeah. Now we're just going to put just a little bit in there until we get right at that 6th line. There we go. Perfect. So now I have my powder. I'm going to grab a knife right now, which will represent my spatula. And I'm going to slowly pour my water in. Now I'm going to do the technique of spatulation, which is when you mix everything together by forming a mound and then spreading it out. So now that I've gotten a pretty decent consistency, it's time to add color. So I have different colors right here, and you should add about 2 drops. So 2 drops of the same color, 2 drops of something different, so you can mix them up whatsoever. I'm going to, let's see, I want to make like a peachy color. So I am going to take a drop of orange and a drop of pink. One. And one. Okay. And once again, mix them up using spatulation. Okay, so now that my color is pretty well mixed, now I can go to this table, use my paint as I'd like. After I'm done with that, you can move over to this table right here and package up your paint. So here I'm going to take an ointment jar and scoop up my paint and put it in here. So after putting your product in the jar, make sure to take the masking tape and label it, and then put it into a prescription bag for the pharmacist's final check.